Many of you probably know white dwarfs, but what on earth are black dwarfs? I will explain everything about this mysterious form of stellar corpse in this video. If you like it, give it a thumbs up and leave a comment for the YouTube algorithm so that the video gets shown to even more people. Thanks everyone, and let's get started. When you look at a beautiful sunset on a warm summer evening, you might get the idea that this could go on forever. Our sun will provide the earth with warmth, light, and energy forever, and everyone is happy. Peace, joy, and pancakes. But fortunately, that's a wrong thought. Our sun, just like all other stars, doesn't exist forever. It will eventually die. Even though this period is extremely long from a human perspective, our sun is about 5 billion years old, and it will exist for another 5 billion years. That means it has now arrived at the middle of its life. If it were a human, it would now be perhaps 40 or 45 years old at the height of its powers. But in 5 billion years it will be over. By then, our sun will have used up its main fuel, namely hydrogen. What is happening in the sun at the moment is that it is fusing hydrogen to form helium. Helium, that is the stellar fusion process, and that generates a lot of energy, as you can see. And at some point, of course, the hydrogen is all used up. What happens then? The sun condenses a bit, which increases the temperature, and now it is able to fuse helium into carbon. The sun expands and becomes a red giant. This is also called shell burning. But our sun is not a particularly large star. That means it can't fuse all the way up to the heaviest element. At some point it comes to an end, and there's no explosion, no supernova. It will simply collapse in on itself, so it will implode. And a dense remnant is left behind, a white dwarf. This white dwarf will still have approximately the same weight as the sun, because the sun is not gone. It has just been compressed down to the white dwarf. Just imagine if you took the sun and squeezed it down to about the size of the Earth. That's a white dwarf. So an incredibly dense object, and white dwarfs, or at least that of our sun, consist largely of carbon, and as some of you probably know, compressed carbon is also called diamond. So basically a white dwarf is a gigantic diamond, and the residual heat of the star is immense. On the surface of a white dwarf, it can even be hotter than on the surface of the sun because the surface is much smaller overall, so flying there and mining the diamonds will be very, very difficult. So much for that, but how do we get from white dwarfs to black dwarfs?